It is interesting to note that the algorithms for addition and subtraction are just as valid in base 5, or any base, as they are in base 10, and that the notation can be developed using manipulatives just as for base 10. For example, the place value cards in base 5 would have a unit square, a 5's chain, a 25's piece, and so on. Alright, let's go ahead and use base 5 blocks to represent 32 in 3 different ways. Which way uses the smallest number of blocks? Well, you can find a set of base 5 virtual blocks in GeoGebra. That's what I have here. And let's say you see there's the 1, there is the 5, and there's the 25 piece. So let's start off. Let's see, there's 5, 10, 11, 12 of them. Then that make it 17, 22, 7, 32. So there's one way to write 32. I could get rid of 5 of those 1s and add one of the 5s there. There's another way to write 32, where you have 5 5s and 7 1s. So like 5 nickels and 7 pennies. I could also replace those 5 1s with a 25 piece. So you think of it like a quarter and 7 pennies. That's also 32. But the smallest number of blocks, think of the smallest number of coins, would be 1 quarter, 1 nickel, and 2 pennies. So 1, 1, 2. Which is why when we write 32, that can be written as 112 base 5. Those are the smallest number of blocks needed of each type. All right, when it comes to addition, here's an addition table for base 5. You're only dealing with the digits 0, 1, 2, 3, 4. So in this case here, right here would be 4 plus 0 is 4, or 0 plus 4 is 4. This one right here, 3 plus 3 comes out to be 6, but you can think of it as a nickel and a penny. So 11 base 5. This one right here is 4 plus 4, that's 8. That's a nickel and 3 pennies. And again, these are all base 5. So if I want to find the sum of 143 base 5 and 234 base 5, I can add using the standard algorithm. So I would start off 3 plus 4, that's basically 7, but that's in base 5, that's 1, 2. So as we do before, I'd put the 2 in the 1's place and carry over the 1. And now, so 1 plus 4 plus 3, that's 8 in base 10, but that's 1, 3 in base 5. So I'd put the 3 down and carry over the 1. And then 1 plus 1 plus 2 gives me 4. So 143 base 5 plus 234 base 5 is 432 base 5. One way to check this is you can convert all these numbers into base 10 and see if it still holds true in base 10. So 143 base 5 is basically a quarter, 4 nickels, and 3 pennies. So 25 plus 20 plus 3 is 48. 234 base 5 comes out to be 2 quarters, 3 nickels, and 4 pennies, or 69 cents. 432 base 5 is 4 quarters, 3 nickels, 2 pennies. And since 48 plus 69 does come out to be 117, this still checks. Okay, so let's try 2 more of these. 23 base 5 plus 34 base 5. Again, I start out with 3 plus 4. That's 7, which is 1 nickel and 2 pennies. So 2, carry over the 1. 1 plus 2 plus 3 is 6, or 1 nickel, 1 penny. So 2, 3 plus base 5 plus 3, 4 base 5 is 1, 1, 2 base 5. Now 4, 4, 4, 4 base 5 and 3, 2, 1 base 5. You would start out 4 plus 1 is 5, which is 1 nickel and 0 pennies. So 0, carry over the 1. 1 plus 4 plus 2 is 6, 7, which is 1 nickel and 2 pennies. 1 plus 4 plus 3 is 8, which is a nickel and 3 pennies. And 1 plus 4 is 5, which is a nickel and 0 pennies. So 4, 4, 4, 4 base 5 plus 3, 2, 1 base 5 is 1, 0, 3, 2, 0 base 5. And I'll leave the second one for you to verify, but let's go ahead and verify this first one. So 2, 3 base 5 is really 2 nickels and 3 pennies. So that is going to be 2 nickels, so that's 10 cents, plus 3 cents is 13 cents. Plus 3 nickels and 4 pennies, that'd be 15 plus 4 is 19 cents. And for this one here, that would be a quarter nickel. A quarter and a nickel is 30 cents, plus 2 is 32 cents. And, well, 13 plus 19 is 32 cents. So this does check. Same holds with part B.